Hello, everyone. How are you today? I hope you're doing well. If you can see me and hear me, please just send a quick yes or thumbs up or something in the chat. It's on the right-hand side there. You'll see, thanks, Ala, Leela, Ryan. Wow, that was really quick. You guys are really on it. Thank you for letting me know. As you've found the chat, you'll also see at the top there, there's a questions tab, there's a polls tab. The polls are for me. I'll throw a few things up there. And when I say, hey, go check out the poll, that's where I want you to go and just answer the questions real quick. If you have a question, please put it in the questions tab, which is in the middle there. If you throw your questions up in the chat, we might not see them, depending how many people are commenting at once. So just make sure they're in the questions tab, and then we'll get to them at the end of this workshop. Thank you so much for joining us today. We're very excited to have you here. I'm just going to mute the notifications so I don't hear all the dinging and you guys don't hear it either. So what are we getting up to today? You have joined Intro to C# with Unity. My name is Shea Coburn, and I'm the community manager for CircuitStream. I have been working in tech and healthcare for over 5 years. Prior to CircuitStream, I was working with a company named Arbor. They're a startup that's helping people align their spending with their values. Prior to that, I was with the Hunter Hub for Entrepreneurial Thinking. We helped people set up their new businesses, access the resources and organizations that they need to get off the ground. And before that, I was with W21C Research and Innovation, which does exactly what it sounds like, research in medical innovation. That was actually my first experience with augmented reality. They were training people how to stick needles into people's necks using AR. So definitely important training. Really happy to be with CircuitStream now, getting the chance to educate all of you wonderful people. And a fun fact about me that you probably have seen on the slide here is that I have an Elvish tattoo. So for all of you Lord of the Rings fans out there, hey, that's me as well. Today, we're going to be joined by Jerry Medeiros, who is one of CircuitStream's lead instructors and an XR designer. He's a game development and AI expert with more than 10 years of experience, and he is a Unity certified instructor. He is from Sao Paulo, Brazil, which is where he's joining us from today. I'm in Calgary. Where's everybody from in the chat? You can just throw up your city there. Super curious to see where you're all from. Montreal, Florida, my gosh, Denver. Taking a quick break from waiting for those election results. Seattle area, Spokane, Pennsylvania, California, Sweden, NYC. My gosh. Oh, someone's in Hawaii right now. I'm very jealous. I would love to be in Hawaii. It's going to snow tomorrow in Calgary, so, not the best. Well, thank you so much for sharing that. Our team, as I've mentioned, I'm in Calgary, Jerry's in Sao Paulo. Our team is located all around the world. We have over 20 team members between our instructors and the rest of our team. As you can see, they're pretty much everywhere. So all of you people who are in Europe, we've got people over there. We've got people in Africa, in Russia, in South America, North America, pretty much anywhere we probably have someone located there. As I mentioned before, Jerry is a Unity certified instructor, and CircuitStream itself is also a Unity certified training partner. What does that mean? It means that we have been approved based on our expertise, our focus on quality education, and our commitment to providing the highest level of training available. So you're in the right place. These are just a few examples of some of the companies that we have worked with. Our emphasis at CircuitStream is working in education and training. So we've worked with the US Navy, we've worked with Walmart, Boeing, Facebook, Nike, Hershey's. I mean, like augmented reality chocolate, who doesn't want that? Might be kind of hard to eat, but these companies are pushing the boundaries of tech development and are world leaders in cutting edge technology. It's an immense pleasure to contribute to the big things that they are accomplishing. And it just goes to show that, the potential for AR, VR is so across the board and in so many industries. We offer a few different things at CircuitStream. Arguably, this is our flagship program, our XR Development with Unity course. This is a 10-week course offering 40 hours of instruction, which is a combination of live in-class sessions and one-on-ones with instructors. Our next cohort for that starts on December 1st, which is like less than a month away. That is absolutely wild. This is probably the most relevant course that we offer to everybody in the group today, C# Scripting Fundamentals in Unity. So if you like what you see in this workshop today, you can take that even further by taking this course. This is only a 3-week course. You get 12 hours of live class time, and it will be taught by Jerry, who you're going to meet today. The next cohort starting November 9th, which is Monday. So if you are interested in learning and you've got the 3 weeks, you should definitely check this out. It's only $199, so definitely well worth the price. I'll talk about this a little bit more later on. Don't want to take up too much of your time right now. Another course that we offer is our XR Project Accelerator course. So if you're feeling a little more advanced, you've got a project you're already working on, this course is the one for you. 8 weeks long. Next cohort is January 5th. It's also live online. The difference is you get 24 hours of in-class sessions and then 24 hours of one-on-one with instructors. So you really get to hone in and work on your projects and figure out all those nitty-gritty details. Lastly, we also offer one-on-one mentorship. So if you're thinking, I don't know if I need a course right now, but I do have some questions, things I need to work on, you can definitely just purchase a couple sessions, 1 session, 3 sessions, 6 sessions, whatever you need to get your project going. So that's something else that we offer. Additionally, in addition to our courses, we also have a community Slack channel. So you've probably already noticed the chat gets pretty lit in these workshops. Everybody's chatting, everybody's making great connections. If you want to keep that going after this workshop, please feel free to join our Slack channel. It's a great place. We answer questions, we share news, we share events, new workshops that are coming up. It's just a wonderful place to meet people who are like-minded and also interested in the XR community. So today, what are we going to cover? You're going to learn a lot of things in a very short amount of time. You're going to create and test C# scripts. You're going to use variables and data types, conditional statements, logical operators, how to use loop statements, and how to use methods and functions. Very exciting stuff. I've already mentioned that we are a Unity certified trainer. What is Unity though? So if you're brand new to C#, possibly brand new to Unity, I can tell you a little bit about it. Unity is a free 3D development engine for building games, simulations, and experiences, and is by far the easiest way to begin making applications for XR, which is AR and VR. So you're in the right place to get your base in C# so that then you can go into Unity, you can build all sorts of wonderful things. This is where Unity fits into the overall development, journey, you could say. So you've got your idea, which is represented by this light bulb here. You would take your idea into Unity and Visual Studio in order to bring it to life, put it through a software development kit, which would then transfer it into your device of choice, which you can see a few examples down the side there. So this is the whole process. We're kind of at the beginning in this workshop, but definitely you're not too far off from getting started in this process here. All right, so without further ado, I would love to introduce you to your instructor for today's course, Jerry Medeiros. He will come on stage and you're going to spend the next 30, 40 minutes with him, and then I'll come back at the end of the workshop. Hey, Jerry.
Hello, everyone. Before we start, please let me know if you can see me and hear me well. Is it okay? Good sound, good video? All right, great. Cool. Amazing. So let me just start sharing my screen here, and we can get started. There we go. Please let me know if you can see. It's good. All right, cool. So today we're gonna go into C#. I'm gonna start with the very, very basics, and my intention here is to demystify it for you guys so you can get more comfortable, more confident, and start learning it and building your XR applications in the future. So the first thing that I would like to tell you guys is that learning a programming language such as C# is not something simple. It requires that we dedicate some time to it, that we practice it, and it's very similar to learning a new language. So if we speak, as I do, Portuguese and trying to learn English, French, or German, you need to get comfortable with the vocabulary, what are the words that exist in that language, the syntax, how can I use the words and how to form sentences. So basically this is the same process. It's like learning a natural language, and we need to practice a lot until you can make it perfect. But there are a couple of differences, and the first one is that learning a computer language is a lot easier than learning a natural language. Some people don't believe me when I say that, but the thing is, if we're trying to learn French, for example, There are so many words, so many grammar rules, and you need to learn all of those. When we are dealing with computer language, there's just a couple of instructions. Like in C Sharp, for example, we don't have more than 100 words that we need to know. What makes a different project or a different application is basically how we use those 100 instructions in different orders. So our job here is basically learn those things and then know how to use them to solve problems. One big difference, though, is that in computer language, we don't have ambiguity or vagueness. So I cannot just say, for example, add a pinch of salt. The computer must know what a pinch means. How much is that? So we need to remove all the ambiguity so we don't cause problems that we usually call bugs. So that's the main difference. We need to be very, very specific about what we want. So the computer is just going to do exactly what we say to do. It's not going to think about it. And this is something different from natural language. So how do we start? The first thing that we need to try to start to do is think as a programming language as a tool to solve problems. So basically what we want to do is solve a couple of problems with this programming language. And then we can think about how can I break down those words that I learned, those sentences that I learned in a way that they can actually end up solving my problem. So let's think about a real problem here. If we want to calculate the surface of a triangle, for example, there are a couple of different ways of doing that in computer language. The first one would be this, quite difficult to understand. It's like binary code. In the end, what my computer understands is that there is a 0 or a 1. It's basically if there is energy or not. But this is not something that we can easily understand, right? So we have like different ways of representing the same thing. They're closer to our language, to our natural language. So we usually call this like a low-level language. It's closer to the hardware. It's closer to the machine. I cannot understand that that well. And then we have like high-level language. We are closer to what we know. And C# is one of those. So something in between would be like something like this. It's still complex. It's still not easy to understand, but this is doing the same operation, like calculating the surface of the triangle. It's basically loading something and then trying to multiply and divide something. It's still a little bit hard to understand. And then we have what C# is. We call C# a high-level language because it's basically very similar to our natural language. So in this case here, I'm defining something that I call the triangle. It's a class. So triangle is something that I know. I can give it like good names. I know that this triangle has two properties, probably the base and the height of the triangle. And then I can calculate the surface just by returning something similar to multiplying the bases by the height, dividing by 2. So it's very similar to how I would solve that problem in real life, like using pen and paper, but in a computer language. So this is the advantage of using C#. We call C# an object-oriented language. It means that we try to model our real-world problem into the computer in a way that it's similar to how we do in real life. So we have like two basic concepts and important concepts in C# or in any other object-oriented language, with our classes and objects. So the class is a template. It's something that defines something that exists in the real world. So for example, I could create a class that is a car and then tell that my car has like wheels and a velocity and something like that. So this is like the class. And I could create an object, which is like a concrete instance of my car, which would be like a Ferrari or, well, something like that, or Lamborghini, for example. So those are like concrete objects that are instantiated. So if I say, for example, in my class car, that it can be a color, that it can have a color, like, well, every single car can have a color, I can define, for example, a Ferrari that is red. So this is basically like the concrete instantiation of a class. So this is like the most important and most fundamental concept in object-oriented language, and C# is included in that. Another example in here, just similar to the Ferrari one, we can have, for example, a class which is human. So I can define, for example, that every single human in my program must have a name, age, a property that says if it's tired or not, and a couple of behaviors that they can do, like walk or sleep. And then I have an object in here, which is myself, and I have like the age, and is tired is true. So this is like the instance and the state of myself in that at that moment. So every time that we're solving a problem using a computer language, we need to define what exists, what are the properties, what are the behaviors, and how we can call those behaviors based on the properties. Those properties, they must have types. They must have like a specific types. And this is because our computer needs to know how much memory it must allocate to represent different things. So there are lots of different types in C# and in other languages. In this chart here, we have like the most basic ones, the ones that we use more often. In this example here, for example, the is tired, it can be like either true or false. I can have like only two possible values. It is the domain of the variable. In this case, in C# we'd call that a boolean or a bool. So it's basically like a variable or a property that allows me to determine only true or false. We can have numbers, for example, like my age. It could be like 30, 35, 40. And in this case, it could be, for example, the int in here. So the int is basically like another type that represents an integer number. If I would like to define my name, for example, I could just use the string, which is basically a group of characters. So it's like an infinite number of characters. We can place any text in there. And I have a couple more. We can use them later, but those are like the most important ones. But one thing that we need to know is every time that I define a property for something in a class, I need to think about what is the type of this? What can I store in that property? So here, for example, a start, age, and name, they are properties of the human, but they need to also have a specific type. And then what we can call in there is basically, or what we can create with those types is what we call a variable. So you guys probably are familiarized with variables from the maths or other stuff. So for example, here I have like x is equals to 10, y is equals to 90, and z is equals to x plus y. I'm pretty sure that if I ask you guys how much is z, what's the value of z? Let's see who can guess that. Just let me know in the chat. 100, Eric, Adriana, all right. Why 56? All right, yeah, so most of you guys are correct. Just joking. Most of you guys are correct, so it's 100. And how do you know that the value is basically because you guys are already familiarized with the concept of a variable. You just replaced the value of x with 10, the value of y with 90, and then you know the value of z. So this is what a variable is. It's like something that we can replace with a real value in the future. And this makes our code a lot flexible because I can define that human or car class, for example, and just change the value of the variable to have different instances. Cool. So this is basically the building block of what we need to do in order to create classes in there. So we already went to this. And then we have something which is basic as well that we need to use most of the times to write a program, which is a conditional statement. So given that I already know that my is tired can be either true or false, I can check that using what we call an if statement. So basically I can write like, if I am tired, then go to sleep. So I'm just thinking about the behavior that I want to implement in my program, but in natural language. So it makes my life easier when I am actually implement that. And then we have the else, like, well, if it doesn't happen, if I am not tired, go for a walk. This is the conditional statement. We can have like operators. We can check, for example, if my age is greater than 30 or not. We can check if the color of the car is red and things like that. In C#, it looks a little bit like this. So it's not as neat as in natural language, but it's very similar. So basically, this is a syntax of when we want to write an if statement. We just need to check the condition, the variable against the condition, and then call the functions that we want to execute in there. We're going to write that or something very similar to that in Unity in a while. So don't worry. I just want to make sure that everyone understands the concepts before we write the code. Another thing that is very, very important or very useful in C# and in other languages as well is what we call the loop statements or repetition statements. It's basically like, say, for example, I want to execute something multiple times. I don't need to write them or to call those functions multiple times. I can just use one of the repetition statements that exist in there. So say, for example, that I want to go for a walk every day of the month. in natural language, we would define that as something like this, like the current day is 1, say for example, the first day of the month, the last day is 31, and then for each day in between, we call the go for a walk. So this is how we define that in natural language. And in C#, it's very similar. So we have what we call a for statement. This is the syntax of the for statement. It has 3 parts. So the first one is where we define the starting point. The second one is where we define the condition. While this condition is true, it's going to repeat. And then we define the increment. So in this case in here, I start at 0. I check. 0 is still less or equals to 31. Yes. Then I call walk. Then I increment 1 in here. Now my I is 1. And then I check again and again and again until this condition is not satisfied anymore. And then in this case, I stop executing this. Let's check how it works in Unity. So before I go into Unity, let me see if there are any questions here that I can quickly answer before I jump into Unity. I don't think so. Actually, C# very similar to Java. Yeah, it is. It's very similar. There are a couple of differences, but they are not super. They're not super different. If you know one of those, you're gonna get comfortable with the other one. So I will start sharing my my screen here at this point and share the entire screen so you guys can see my Unity editor. There we go. So this is my Unity editor. If you guys have never seen Unity before, this is how it looks like. The Unity editor is composed of a couple of panels in here that we can move around, that we can interact with. And the most important ones are, first, the hierarchy. So here in the hierarchy, we have every single object that exists in the scene. So we have, for example, by default, every time that we create something in Unity, a new project in Unity, we have the main camera and a light in here. So those guys are game objects or components that we have in our scene. Here we have the scene view where we can actually edit the scene. So if I want, for example, to move the camera or to move the light, I can just use the scene view for that. Here on the right, I have the inspector. This is very useful as well. This is where we actually change the properties of our objects. So if I want to move the position, or if I want to disable something, or maybe change the color of the light, we can change all of the properties that exist in the inspector in here. And as I have just defined, those things are variables. So basically when we create, we can understand that this transform is a class. So this class has 3 properties or 3 variables: a position, rotation, and scale. And those things are groups of numbers as well. So basically every time that we create a variable in a class, we can edit that in the inspector. And this is something that Unity makes super easy. Here on the bottom, we have the project view. This is where we're going to see all of our assets. So if we import, for example, an image or a 3D module or an audio file, you're going to see all of them right here in the project. Cool. So let's start with a simple script. How do we create a script, a C# script in Unity? We just need to right-click here anywhere in the scene, create, and then C# script. I'll just click this. For now, I will call it the simple script. And then we can start playing around with scripts in Unity. Every time that we create a script, and I'm going to open this one, Unity already creates a class for us. Let me show you. Still opening. As soon as it's open, I'm going to show you the basic structure of a class in C#. While it opens, one thing that we need to mention is that, well, the scripts in Unity, we can create as many scripts as we want, but nothing in them execute unless they are assigned to something in the scene. So we need to drag this script or assign this script to an object here, and then we will be able to play this script or to execute the behaviors in those scripts. We could use any one of those scripts in here. So if we're making a script to change the camera properties, we can just assign that to the camera. But now, given that this simple script is not related to the camera or to the light, I will create an empty game object here just to display or just to execute my script. I'll right-click and then create empty. And here I am. So an empty game object is something that is not rendered. So it's basically like a placeholder where I can put my scripts in it. As you can see here, it has a position, rotation, and scale because every single object in Unity needs to have it, but it's not rendered. We don't see this anywhere. So I will rename this to simple script. The name doesn't matter, doesn't really matter. It's just so we know what it is. And I will drag my script here to this object right now. So now this is executing. Every time that I open it, I can change the behaviors in here and see how they go. So this is how a script, a C# script looks like when we create it from Unity. Every time that we create it from Unity, it's going to be a class. As I said, the class is the template. We can reuse this class in multiple instances or in multiple objects. And Unity always adds this mono behavior in here. This is like a Unity thing. You don't need to worry too much about that. But if you want to assign this script to something in the scene, it must be here inheriting from mono behavior. Those things are automatically added here for us as well, like the start function and the update function. Those are magic things that Unity does with the mono behavior. So we just need to understand that those functions are called automatically by Unity. We don't need to do anything in different moments. So the start function, for example, is called only once. Like as soon as I hit play, as soon as I start my application, every start function is going to be called once. And the update function, it's like a game loop. It's something that is repeating every single time based on the frame rate. So say, for example, my application, my game, or my XR application is running at 30 frames per second. It means that the update function is going to be called 30 times per second. So here is where we update positions, update the UI, we draw things, calculate whatever we need to calculate for every frame. But we need to be aware, if you bloat this function with too much things, it might be slow it down. But we're going to use those in a while. Let's just start creating variables in here. As we have been seeing in there, we can add different data types to our variable. So that must be explicitly said in Unity. So if I want to create, for example, like a name, I need to create here string name. So this is how we declare a variable. So we just need to give it the type and then the name that we want it to have. So if I want to create an age, for example, I can just call it an int and then age. So the syntax for creating a variable is this. We need to have at least the type and then the name. Every single instruction in Unity, or not in Unity, actually in C#, must end with a semicolon. So if I don't place the semicolon in here, my editor is going to complain, and Unity is going to complain as well. So if I just go here, it just complains that it's expecting a semicolon that I didn't place. You guys have noticed that every time that I save it, my editor is just adding this private in the beginning here. So this is another thing that is optional that we can add to a variable. It's what we call the access modifier. So we can either declare it as private or as public. The difference between them is if I make this private, I cannot change the value of this outside of this script. So only here in those functions or in this script, I can change this. If I make it public, then I can modify that from everywhere. Let's make this public for a while, and I will show you guys one magic that Unity makes when we have public variables in our scripts. So I have two different types here, like the int and the string. This is for text, this is for numbers. If I go back to Unity, and this is something very interesting about Unity, it's going to do something that we call serialization. So I have my variables in here, and I can actually add values to them. So I can change, for example, this simple script and call it simple1 and give it the value of 10, for example. And this is the materialization of class and object. So the class is here, is the template. I didn't give any value to it. And the object is here, and I do have a value for this. And the value can be different. Like I said, we can have a Ferrari and we can have a Lamborghini. Here is the same. I can create another game object, drag the same script here, and give it different values. So it could be, for example, script 2, and then the 8 could be 50, for example. So now I have 2 instances of the same object, and they have different values in there. So now let's do something more interesting using like an if statement, and then we can move to the for statement. Those are the things that I want to show you guys. So let's start with an if statement, for example. I will create a couple of objects here so we can visualize stuff. I will just right click here, create, and then select a plane. So here in Unity, we can actually import 3D models like characters, environments, but we can also play with primitives, which are cubes, spheres, and things like that. So I'll just create a plane in here. This is a plane. I will pretend this plane is my ground, for example. There are a couple of tools in here to manipulate them in the scene. So I can, for example, just rotate them. I can scale them and things like that. So this is basically my my plane in here. And now I will create another script. So what I want to be here, let's think about, for example, house automation. So I want to turn on a light when I am close to something, and I want to turn off the light if I'm not close to that something. So let's see how we could do that using a very simple script in Unity. The first thing is I want to create a light in here. So to create a light, we can just right click and then create click on light, and then we have different types of lights. For now, I will create a point light. So a point light in Unity is basically like a light bulb. You can see that this is illuminating my plane right there. And we can turn it on and off by checking this thing here. This is another variable, which is a Boolean. As we've seen, we have like every single Boolean can hold either true or false. So in my light here, it's true. The enable of this light is true. If I uncheck that, the enable of this light is now false. So let's see how we can quickly access that property using a script. So let's create one more script in here. I will right click, create C# script. And we can call that anything that we want, but I will call it light controller, for example. And then we just need to assign that to my light here, as we did with the simple objects. Now we have the light controller here. The light controller doesn't have any properties, so we can see anything here, but we can actually open this and start editing that. What I want to do here is first, I want to have a variable that determines whether my light is turned on or turned off. So let's create here a public Boolean, actually bool, is turned on. Spell that is turned on. So this is another variable. By default, every single Boolean in C#, if you don't give it a value, the value is false. So what we can do is, as soon as we declare a variable, we can also give it a value, like an initial value. So I want it to start as true, for example. As I said, the update function is called every frame, and we can use an if statement, the conditional statement, to check the value of this variable. So let's do that. Every single frame, I want to know if that's true or false. So I'll check here. If, so this is the syntax of the if is turned is equals to true, I want to do something. And notice that when we are comparing things, we use the double equal sign. This is the operator to compare this part with this part. The reason why we don't use just this equal, because this is an assignment. So here I am actually giving it a value. When I want to compare the value, I need to be aware of the two, the double equals here. If I just delete this, then it's incorrect. It's assigning true to this variable, and this is not what I want. So here we can do something else. We can do something else. Basically, in the update, every frame I'm testing, is this variable true? Yes, then do something. Otherwise, do something else. Before we actually change something in that light, let's see how we can debug stuff. So I want to know what's going on in here. In C# and in Unity as well, we have a very handful function which is called print. So this print function doesn't do anything in the final application. It's just for debugging and testing, but we can pass a string or a text in here, and it's going to be printed in the console, so we know what's going on. The console is another window here in Unity, and it's basically like a log of every single thing that is going on my application, like errors, warnings, or messages. And I can say here, for example, is on. And I want to use text. Every time that we want to use text from the code, we need to use quotation marks. So the C# knows, the C# compiler knows that this is text, it's not a variable. So otherwise, it wouldn't be able to distinguish between whether is turned on is a text or it's a variable name. So if we want to refer to text, we just use the quotation mark. So actually, it is on. Otherwise, else we can just print is off. It's not doing anything like super powerful, just debugging the value of the variable, and we can already see it working. So let me show you guys how it works. If we want to debug our scripts, we need to go from what we call edit mode, where I'm developing and creating my scenes, to what we call play mode. So for that, we need to hit play. As soon as I hit this play button, it's going to run every single script that exists in here. And we should be able to see something happening in the console. So I'll just hit play here. The update function is called, oops, it's maximizing. I don't want it to maximize so you guys can see. I will hit play here again. And you can see that is just saying here is on over and over and over again. This is because if I select my light, we're going to see that this is checked. It means that my variable has the true value. As soon as I uncheck it, now it's not printed this anymore. It's now printing is off every single frame. So the update function runs every single frame, and then we make a conditional here to see what's happening. So now I want to see it affecting a game object that exists. So I want it to actually change the value of the enable in this light in here. Let's see how we can do that. It's quite easy. So here I have a reference for a Boolean. We can also have a reference for complex objects in Unity. So I can declare a variable here to hold a reference to that light. So we just need to use the right type, and the right type is light in Unity, and we can call it anything. So let's just call it light here. Again, just reinforcing how we declare a variable. We need at least these two things, but we can also have a modifier. So I'm telling Unity that I'm creating a public variable. It means that I can access that from the editor and from other classes. Then I give the type. So this is like a simple type, string, int, boolean. And this is a complex type, which is light. Light is a class from Unity. And then the name. Now, if I just go back there to the inspector, I can drag my light right here. And now I have a reference to it. So now I have two variables here. One is the boolean, one is the light. This light is pointing to this specific light. And now what I can do here is, instead of only printing that, I can modify a property of this light. So I just right click this. Oh, actually, I'll just type here light dot. Those are the variables that exist in the light. So we have color, we have flare, we have intensity, we have enabled, and this is what we're looking for. So I can just make this enable equals to true here. Otherwise, I can do the same thing, like light dot enabled is equals to false. So now every time that I press that button, like that I make the variable become true, it's gonna also change the enabled of the light, and it's going to turn on. And when I uncheck that, it's going to change the variable to false, and the enable of the light is false as well. So let's see that in action. Now I should be able to see the light turning on and off if everything is correct. So here I have my light, I have my scene, I selected it. For now it's turned on. If I click, now it's off. So basically, I am controlling the behavior of the light based on a variable, a Boolean variable. So coding is pretty much like that. So I defined my problem. I want to, every time that I turn this switch, turn the light on or off. We could, for example, test if the distance from another object is greater than a threshold and then turn that off. So there are many things that we can do. Now, the last thing here to make it a little bit more complex, say, for example, we had, instead of only this light, only one light, we had multiple lights. So I'll just duplicate this light. To duplicate something in Unity, we can just use Ctrl D or Command D if you are in a Mac. Now I have multiple lights here. Let's see how we can turn all of these lights off or on at once. And for that, we're going to be using a for statement, a repetition statement, as I mentioned in these slides. So the first thing that I need to change in here is, now I don't want to hold only one light. I want to hold multiple lights. So this variable must change the type. And every single type that we have, we can have also a collection of that. And in C#, it's quite easy to do. So instead of declaring the type, we use also always the type in the brackets here. So what it means is, instead of one light, I have what we call an array of lights, a collection of lights. We can do the same thing for the Boolean. We can do the same thing for every single option, for every single variable type that we have in there. So now, if I just go back to my editor, oh, it's not going to show anything because there are more things that we need to fix. Given that now I changed this to a list, I cannot just access this light anymore because it's not a single instance. So let me remove this just for now to show you guys how it's going to look like in the editor now. So given that now I have an array or a collection instead of only one, it asks me for a size. So basically how many lights I want to assign here. And I have 1, 2, 3, 4, 5, 6. So let me just make it 6 and drag one by one here. So the first one goes here. The second ones go here. The order doesn't really matter because I'm going to loop through all of them. We're going to just check every single light and turn them on and off on for each loop. So now instead of one reference, I have multiple references here. Now we can go back to the code and use the for statement instead of only changing one. So how we use the for statement? As you've seen, we need to declare it like a for. There are three parts, as I mentioned. The first one is we need to declare a variable that we're going to increment. So it's going to be, usually we call that I, just as index to make it easier, but it can be named everything. And we give it initial value. One important thing to know about arrays in C# is that they are indexed from 0 to the length. So if I want to access the first, light in here, this is the light 0, not the light 1. And then I have 1, 2, 3, 4, and 5. So I know that a couple of languages have index starting from 1, but C# starts from 0. So that's why I'm going to start from 0 here. Then I need to have the condition. So when do I want to stop this? I want to stop this when I am in the last light. So I just need to check if I is smaller than my lights variable in there. How do I call that? We call that light. I will rename it to lights instead. Lights dot length. So length is how many elements that exist in this array, and then the increment size. Plus means just my plus 1. And then here, this is going to be executed one time for each light in this array. So if I add more or less, I don't need to change the code because this is generic enough. So this is why we use the for loops. And now we need to change the light to enable or disable for every single one. So I just need to access the lights in the specific index. So if I do this, I'm accessing the light in a specific position. I could use 0, for example, or 1 or 2. But it's better for us to access that in I, because this I is going to change automatically from 0 until the last position. And then I can just call the enable is equals to false. So here I'm looping through every single line that exists in there, every single light that exists in there, and making them disabled. But actually what I want here is to make them enabled. And in the else, I want the same thing, but the other way around. So I just copy everything, so I don't need to type it again, and just replace here for false. Now I'm using an if statement and the for statement in the update function, which are mostly the most basic statements that we use in C#. Let's see if it works. I'll hit play. Now what I expect is that if I uncheck this, all of the lights turns off. And if I turn in all of the lights, this is a problem. I changed the name here. So given that I changed the name, now I have no more lights in here. Let me assign them again. They are 6. 1, 2, I forgot this one. 3, 4, and 5. There we go. Now it should work. I didn't have references, so it was going from 0 to 0, meaning that nothing was changed. Let's see now. So I have all of them turned on, and then when I click here, they're gonna just turn off, all of them. And if I have more or less, it doesn't really matter. So if I just cap it to 2, for example, it's gonna turn on the first 2. And this is why it's useful to use the for loops as well. And here we have like the basics for a program. As I said, you can solve almost every single problem using C# only with the things that we have in here. Of course, there are more about C#, but this is like 80%. I will go back to a couple of tips, like pro tips in my slides. And after that, I will come back for questions. So let me share my C# back here again. Second. Why it's not working? This one, there we go. Cool. So before I finish here, I would like to just give a couple of tips. Like if you're a beginner to it, if you didn't understand every single thing, don't worry, just take your time. So something that I usually see my students is that they try to compare themselves with the others and the progress of the others. That's not a good idea. Everyone learns in a different way, in a different pace. So just respect that. And if everything looks super cryptic, like you're not understanding anything, you're probably going too fast. So just try to step back, review the concepts, practice a little bit more until you try to learn another concept. Another thing is use examples. Try to find examples online. Like there are good resources out there that you can see, you can try to understand, we can modify them. So if everything seems too complex for you, try to find a couple of examples that solve the problem that you're looking for. This usually helps us to learn as well. Another thing is try to plan before you write code. Like try to write things in pseudo code, like in natural language, so you can start to work out your ideas and find problems before you go into the code. Because if you try to solve like the logic problem and the syntax problem at the same time, you might get frustrated. So what I recommend is think about the problem, think about how you solve the problem, try to solve that in natural language using the if and the while this happens. So try to describe your problem in natural language until you're comfortable to go to the code and then just write that. So planning is really important, especially when you don't have enough coding experience. This is another good tip. You should try to figure out the problems on your own, but if you're spending too much time on that, you should ask for help. So I often see people like spending days, weeks trying to solve a problem, and sometimes, or most of the times, it's a very simple problem, like, well, it was missing an operator, or the condition was not written correctly. So if we're struggling too much with something that is simple, your frustration level is going to increase and your confidence level goes down. And then most of the people just quit in this part. So don't be afraid of asking for help, either online or, well, subscribing to one of the courses, getting the one-on-ones, but try to find someone that can guide you, that can lead you to the right solution. Of course, it's nice to try to find the solution on your own, but if you're spending too much time on that, well, that might not be the best way. So I think that's it. I will invite Shea back again to wrap up, and in a couple of minutes, I will join to answer all of your questions if they exist.
Hello, everybody. Another quick thing, just tell me if you can hear me.
Oops. Something. Okay.
Okay.
There we go.
Now can you see me and hear me after Jerry kicked me out? Hey, everybody. Thank you so much, Jerry. That was fantastic. As always, I learned a lot. Sorry it's a little dark in here, everybody. Let me just see if I can adjust my lighting a bit. That's not really better, but anyways, bear with me. I'm going to run you through a couple last things, and then we'll come back to Jerry to go over a few of the questions. Before we do that, I would love to hear how you felt about this workshop. This is your very first and probably only poll that you're going to have to do. So beside the chat, next to questions, there's a polls tab. If you could just quickly go in there, click a number, hope you liked it, let us know what you think. I do want to mention just a little bit more about CircuitStream. As Jerry mentioned as well, we work with a variety of different people. We've got everybody working with us, from someone who's independently building their own app to someone who is working with their company to build something for the company. And then we've got entire organizations who are sending multiple people to us to learn training. So no matter what your needs are, we definitely have something for you. As I mentioned earlier, the C# scripting fundamentals in Unity. This is our upcoming course on November 9th. So if you liked what you saw today, you want to take it further, you want to learn a little bit more, you think Jerry's amazing, this is the course for you. Starts on Monday. So definitely get in touch with us. I think you've already seen Kyle, Vlad, Steph there in the chat. They are our course leads. So if you have any questions, do connect with them in the chat directly or on LinkedIn. They can shoot you an email, whatever works best for you. We also have our XR Development with Unity course. So if you're like, oh, you know what, C#'s great, I already know so much about it. Or even if you don't and you just would like to take a little bit more of an in-depth course, this is definitely the best option for you. Our next cohort is December 1st. And this course is going to go into a variety of things. So definitely some C# fundamentals, but also getting deeper into Unity for making your VR, AR apps. There's 4 hours of class per week that includes one-on-one sessions as well as live in-class sessions. Dan's just shared the C# scripting course up at the top there, as it says there, only by the end of this week. So if you are interested, do get into that. But also check out the XR Development with Unity if you're looking for something that's going to take you a bit further past the C#. We've also got the XR Project Accelerator course. This is for people who are already in the midst of building one of their projects and they just need that little extra push. This has much more in-depth, like one-on-one time, 24 hours of one-on-one time with our instructors, as well as 24 hours of in-class sessions. We do offer payment plans. So we have 3 months, 6 months, 12 months, and of course you can pay upfront the full amount. It's very super helpful for people if you're looking for a way to kind of spread the cost over a period of time. If you're interested in learning more, you can always go to our website, circuitstream.com/learning. We have all of the information there. Or as I said earlier, you can chat with one of our course leads. They'd be happy to share something with you. And if you have any questions that you think of later, or you want to keep the conversation going, I saw some really great interactions in the chat there. You can join us on our CircuitStream community channel. It's listed right there. We're happy to, keep chatting there, give some news, give some new events, workshops that are coming up. There's all sorts of fun stuff in there, and people will share their projects as well. So if you're looking for some inspiration, check us out there. And with that, I will bring Jerry back and we'll answer a few of the questions. I know there was a bit of an ongoing answering going on during the presentation, but I think there's a couple in here that we'll want to have Jerry go over. So if you do have any questions in the moment, please throw them into the questions tab and we will get to them right now. Hey, Jerry.
Hello, I'm back. So I'm sorry I kicked you by accident. Just pressed the wrong button.
It's all
Let,
good.
let me sort the questions here by upvotes and see if there's something that people ask and no one answered in the background. What's the difference between print and debug.log? There's no difference. Actually, both are the same function. This is what we call an alias. So it's like the same thing. It doesn't matter. I just use print because it's easier to write and easier to explain because it's actually printing too. But that's the same thing. So you can use either of those. Let me see here if I have more questions that were not answered. Yes, yes. Da, 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 da. I cannot see questions that were not answered. Can you see any good questions there?
Let's take a look here. Oh, lots of answers. Guzman was doing a great job throwing some things in there.
Yeah.
Will we be sharing a video of the recording? We've had this a couple times. Yes, because you're registered, you will definitely receive the recording as well as some materials after the workshop. A good website where one can find C# scripts examples online. Thoughts, Jerry?
Yeah, that's a good question. Good examples. That's very difficult to find, being really honest. So what I usually do is you can refer to Stack Overflow. Not sure if you are familiar with that, but it's like a community of practice for programmers in different languages, not only C#, not only Unity, but you can find everything right there. So if you're trying to find out how to anything like how to connect this to Bluetooth or how to calculate the square root or something. Well, anything that you find they're searching there, you're gonna find out. And what I like about the Stack Overflow is that it's a discussion forum. So you're gonna see people explaining why that works or why that not works, and then they're gonna upvote. And this is like a very solid community. You're gonna find every single problem in the world in there. If you're trying something and you don't find an answer in Stack Overflow, you're probably in a bad situation because nobody in the world have the solution for that. So every single problem exists in there. It's good to see how they solve things and what people comment about that. But you have the official documentation of Microsoft MSDN as well. You can go there and see a couple of examples. They're too basic. They're more oriented towards explaining the concept, so you don't see like real examples or real problems being solved in there. So I think I would finally suggest searching on Stack Overflow if you want to see like real world examples. There's another one here. Yeah, thanks DJ Anthony for complimenting. W3 School is great. Yeah, that's true. I like them as well. They're very organized, and you have like every single thing, not only for C#, actually for they are like intended for web. So you have like most of web languages in there, but C# is in there as well, and I like it.
Okay, can you see the questions in there, Jerry? There's a few that popped in the questions tab there.
Yes, sure. Should we use Visual Studio or Visual Studio Code? So this is a matter of preference. You can use any single IDE that exists out there. Personally, on my daily life, I use Rider, which is a lot better, in my personal opinion, than Visual Studio, but it's not free. But Visual Studio is great. So between Visual Studio and Visual Studio Code, in my opinion, I would pick Visual Studio. I think it's more complete. I think it's more well linked to Unity. So for developing, while developing for Unity, I would finally pick Visual Studio. But it's a matter of preference. So I know people that use like Sublime Text or even Notepad or whatever they want. So in the end, script is just a text. The IDE, the integrated development environment, just helps us to deal with the problems in a better way. They point out what is wrong, what is missing, and yeah. So I prefer to use more complete ones. In my case, Rider. But it's up to you. There's another one here. Could you please share final light controller script code again? Yeah, definitely. So we're gonna receive that in the end of the workshop with the recording. So you're gonna receive the entire project. You can download that and experiment with that and see what's different from yours, and also expand that if you want. So don't worry about it. You're gonna receive that as a resource. There is another one here, which is good. Is C# compiled or interpreted in Unity? So that's a complex question because C# is neither interpreted nor compiled. It's like a mix of both. It's more interpreted than compiled. But in Unity, what actually happens is that it changes in a chain, and in the end, it is converted to C++ and then compiled. So in Unity, we use like a very complex stack to make it effective. We write in C#, which is easier to understand, to learn, and to develop. But in the end, it's compiled. It's transpiled to C++ and then compiled into something in the end. So yeah, that's weird. In C#, it's already weird, but Unity makes it even weirder. But I would say it's a mix of everything. There's another one here. Is the print function so inefficient as the debug log? Yes, it's the same thing actually, and both are very inefficient. The thing is, we only use them, or we only use that in editor time. So when we are developing, when we are experimenting, but when we build the application, it's stripped out. So you don't need to care a lot about the debug log because it's removed in the final application. But yeah, they are super inefficient. They're super slow. Both of them, the debug log and the print, are super, super slow. Let me see if I can find more questions. Actually, Ozzy and Jason, they did a great job there answering most of the questions.
Marco's got a question just at the top.
Oh, let me see. I came across, let me see. I came across Visual Scripting Unity tool both the other day and was wondering if this is a good way to go in general, especially as a non-programmer. Well, I think so. Actually, there is a good thing about visual scripting, which is you don't need to learn the code. You just need to learn the logic and how to use the nodes in a good way. So for prototyping, for learning, for testing ideas quickly, that's good. I like that. But it doesn't scale well. So if you have like a big project, like a VR training or a game, imagine having thousands, millions of nodes and all of them integrated. So at some point, you don't know what's going on. So I don't recommend using them commercially, like for a real project. But for learning and experimenting and prototyping, definitely a good start.
All right. Well, I don't see any other questions. Any last questions? Anybody can throw them in there. If you think of something later and you're like, oh, I didn't ask that, feel free to shoot either myself an email or join us in the Slack, throw your questions up there. Oh, we got one more. How many C# scripts can you attach to an object?
Well, potentially infinite. Well, it can add as many as you can think of. There is no limitation. Actually, you are gonna hit the performance bottleneck and also memory bottleneck. So you're gonna, well, virtually you can add as many scripts as you want. But at some point, you're gonna have so many variables in there that you don't have like more memory, or you're gonna have so many behaviors that your processor cannot actually process those. So the answer is as many as the hardware can handle, actually.
One more. Opinions on Unreal versus Unity for newcomers trying to choose one.
Oops. I clicked the wrong one. Opinions on Unity versus Unreal for newcomers trying to choose one. I think that's not easy to answer this question. I think I am a little bit biased as well. I like both engines. I like Unreal. I like Unity, but I think for learning, Unity is a lot easier because that's my opinion. That might not be true, but in my opinion, Unity is easier to learn. There are more. The way it works makes things a little bit easier. And also the language that is in there. Like I think that C# is a lot easier to learn than C++, unless you start learning the Visual Script, like the blueprints for Unreal. So I don't know. I'm not very conclusive for this answer. I would say Unity, but it depends. If you're a beginner, you're a beginner in both. So you need to work your way through that. It doesn't matter the engine. But I would definitely myself. I would start with Unity. I'm done. There's another one. Is XR the same as MR? Not really. So XR is a more broad term. It's like the umbrella term that encompasses every single thing. So XR is extended reality. Everything that is not pure virtuality or pure reality is called extended reality. So mixed reality is in between. Mixed reality is like a specific type of augmented reality, or yeah. So it's basically you're overlaying something on top of reality, and then it becomes MR. So every MR is an XR application, but not every XR application is an MR application. Let me see if I have more. Oh, what's a good web? No, I have answered this. There is this one. I'm not pretty sure I understood it. How Unreal it with compiling the code. I read that it's 100 times slower than compiling C#. And I'm not really sure I got this. How Unreal it with compiling the code. Maybe how Unreal compares with Unity while compiling the code. If Unity is lower than Unreal, maybe. Well, I don't know. It depends on so many variables. So in Unity, building a project, it might take some time or not. It depends on the assets that we have in there and the strategies that you're using. So you can use, for example, cache server or the burst compiler, which is super fast and new. So I don't know. This depends on lots of variables in the project. It's not like a matter of engine by engine, but your project in your setup is super influences this as well. So I don't know. I think he complimented here. It is about the difference between C# and C++. So C# is slower than C while executing, but about compiling it depends. C# compiles a little bit slower because there are more processing there. But this is not something that is super relevant, being really honest, because you're gonna need, independent on the language, if you have like a huge project, it's gonna take a while to compile. So imagine, for example, like a AAA studio that is divided across different countries, and they have like different pieces of the code. They need to compile everything together. So many assets, like the compiled game is 20 gigs or more. So compiling is always something that takes time, and the language doesn't play a huge role in that. It's more the assets and the workflow. So if you have a big project, you need to deal with compiling time. It doesn't matter what language you're using. So yeah, C# is a little bit slower than C. It's maybe like 20%, 30% slower than C#. But in the end, it doesn't matter a lot, because what takes more time is the assets and the workflow.
We've got one question, Francisco Sebastian. He's asking, does completing full paid courses come with certificates? You will get a certificate at the end of the course, yes, from us, and especially for the XR development with Unity, you do get a certificate from Unity as well. I know we clicked on that and then it was viewed as the answer, but okay. Cool. I think you've hit all of them. I don't see any missing questions there. Yeah, so like I said, if you have any questions, drop them in the Slack. We're quite responsive there. If you want to keep talking to some of the people you met here, either from CircuitStream or otherwise, also join the Slack, keep the conversation going. Otherwise, thank you so much, Jerry. That was great. And thank you everyone for joining us. And one quick thing is that we do have another workshop this afternoon if you're interested. Oculus Quest 2 hand tracking. That's at 7 p.m. Eastern time. So if you want to join us there, we'd love to see you. Otherwise, we'll see you hopefully next week at another one of our workshops. Thanks so much, everybody.
Bye.
Bye.